Hello viewers, in today's class we are going to discuss yet another very important and conceptual problem from definite integrals involving the modulus function, right? So here we have to evaluate this integral that is from pi by 4 to pi by 2, and the integrand is the mod of cosine of 4x, right? And here we have dx, right? So in this lecture we'll see how to evaluate this integral containing the mod of cosine of 4x, right? So let us first take this integral as I, right? So in order to evaluate this type of integral, what we usually do, we first make use of the concept of mod function, right? That is the definition of mod function. And then we'll see the concept of sign convention in trigonometric functions, right? So let us see how we can solve these type of definite integrals containing the absolute value function. So viewers, here we see that the limits of integration are from pi by 4 to pi by 2, right? So here x varies from pi by 4 to pi by 2, right? So first of all, let us first make use of the method of substitution, right? So here we'll make use of substitution method to first simplify this integral, right? So let us take 4x is equal to theta, right? So here we have cosine of 4x. So we'll take 4x is equal to theta and we'll introduce this variable theta, right? And x varies from pi by 4 to x is equal to pi by 2, right? So now 4x is equal to theta. So if we differentiate both sides with respect to x, then we'll get 4 times dx is equal to d theta, right? So dx can now be written as d theta over 4, and will also change the limits accordingly. So here x is equal to pi by 4. So when x is pi by 4, then the value of theta is given by 4 times pi by 4, right? So here we'll take x is equal to pi by 4. So 4 and 4 get cancelled, so theta is equal to pi, right? And similarly the upper limit is here pi by 2. So when x is pi by 2, then the corresponding value of theta can be obtained by taking x is equal to pi by 2 in this relation, right? So theta is 4 times pi by 2. So we have 2 2s are 4, so this is 2 pi, right? So we see that when x varies from pi by 4 to pi by 2, then theta varies from pi to pi, right? Now let us write this integral in terms of theta. So now I can be written as integral from theta is equal to pi to 2 pi, because when x is pi by 4, theta is pi, and when x is pi by 2, theta is 2 pi, right? And here we have mod of cosine of theta, because 4x is equal to theta, and dx can now be written as d theta over 4, right? Now here 1 over 4 is a constant, so we can take it outside the integral. So now we have I is equal to 1 over 4 times limits are from pi to 2 pi, and we have mod of cosine of theta, and here we have d theta. So now by method of substitution, we have reduced this integral to this one, right? Now to move further, what we will do, will make use of some trigonometry to simplify this integral, right? So what we will do, we'll try to write this integral as a sum of two integrals, right? Because here we have the limits from pi to 2 pi. So let us take the sign convention for trigonometric functions in the four quadrants, right? So suppose here we have the four quadrants. This is 0, and here we have pi by 2, here we have pi, here we have 3 pi by 2, and here we have 2 pi, right? So this is a complete circle, and now here theta varies from pi to 2 pi, right? So we can display this limit, that is from pi to 2 pi, like this, right? So now see, here we have to integrate mod of cos theta from third quadrant to the fourth quadrant, right? This is the first quadrant, this is the second one, this is the third, and this is the fourth, right? And from trigonometry we know that in the first quadrant all the trigonometric functions are positive, right? And in the second quadrant only the sine function is positive, right? That is sine function, right? And in the third quadrant only the tangent function is positive, right? And in the fourth quadrant the cosine function is positive, right? So here it implies that in the first quadrant all the trigonometric function, all the 6 trigonometric functions are positive. In the second quadrant sine and cosec function, right, are positive, and in the third quadrant the tangent function and the cotangent function are positive, and in the fourth quadrant the cosine function and the secant function are positive, right? So this sign convention shall be used to write this integral as a sum of two integrals. So now let us break this limit from pi to 2 pi, right? So first we'll go from pi to 3 pi by 2, and then we'll go from 3 pi by 2 to 2 pi, right? So now this integral I can be written as 1 over 4, and we have theta is equal to pi to 3 pi by 2, and here we have mod of cos of theta, and then we have the integral from 3 pi by 2 to 2 pi, right? So here we have theta is equal to 3 pi by 2 to 2 pi, and here we have mod of cos theta and d theta, right? Now let us make use of the definition of mod function, right? So when we go from pi to 3 pi by 2, then mod of cos theta is negative of cos theta, right? So mod of cos theta is equal to negative of cos theta when we go from pi to 3 pi by 2, because in the third quadrant the cosine function is negative, right? And when we go from 3 pi by 2 to 2 pi, then mod of cos theta is positive cos theta, because in the fourth quadrant the cosine function is positive, right? And in the third quadrant the cosine function is negative. So here we have used the definition of mod function, which says that mod of x is positive x whenever x is greater than or equal to 0, or we can also write it as mod of x is positive x when x is greater than 0, and mod of x is 0 when x is 0, and mod of x is negative of x when x is less than 0, right? So now this integral I can be written as 1 over 4, and the first integral becomes pi to 3 pi by 2, and mod of cos theta is negative of cos theta d theta, and the second integral is 3 pi by 2 to 2 pi, and here we have mod of cos theta is positive cos theta, right? And here we have d theta. So now we have two simple integrals, right? So now we know that the integral of cosine theta is equal to positive sine theta, right? So here we have I is equal to 1 over 4, and the integral of cosine theta is sine theta. So here we have the negative sign, and then we have sine theta, and limits are from pi to 3 pi by 2, right? And the second integral is, again we have integral of cos theta. So this is sine theta, and limits are from 3 pi by 2 to 2 pi, right? So now we'll simply substitute the limits and we'll take the difference. So we have 1 over 4, and here we have 3 pi by 2 and pi. So we have sine 3 pi by 2 minus sine of pi, and here we have 2 pi and 3 pi by 2. So we have sine 2 pi minus sine 3 pi by 2, right? So now we can simplify it. So we have 1 over 4, and sine 3 pi by 2 is minus 1, right? So here we'll make use of the values of trigonometric functions at certain angles. So we have sine 3 pi by 2 is minus 1, sine pi is 0, and sine 2 pi is 0, and sine 3 pi by 2 is minus 1, right? Okay, so now we have 1 over 4, and here minus and minus plus, so we have 1, and here minus and minus becomes 1, so we have plus 1, right? So this is 1 over 4 times 2, so this is 2 2s are 4, so we have half, right? So the value of this integral I is equal to half, right? So viewers, this is how we can solve these type of definite integrals.